Subhash Kak is a professor of electrical and computer engineering at Oklahoma State University. His research focuses on AI and quantum computing. Subhash, thank you so much for taking the time today.
Glad to be on your show.
So to start, could you describe to the audience what are instantaneously trained neural networks?
Well, in the mid 90s, when I was working on neural networks, the idea came to my mind that we have back propagation. We train neural networks to learn memories, and that takes a long time. And perhaps back propagation can be compared to long-term memory because we know long-term memory is more stable than short-term memory. Now, short-term memory, we see a scene and it sticks to our mind in case we want to hold on to it. So there should be a mechanism for short-term memory. And that led me to uh, discovery of an algorithm which takes no time at all. The information comes in and it's instantaneously learned by the neural network. And I used it for financial data prediction. We got a patent. It was sold to industry, and we don't know what other uses it's been put to because that patent expired, I would believe, in 2010 or so. But that also led to the idea that such a neural network could be the basis of an AI-based search engine, much before the current LLMs such as DeepSeek or ChatGPT or Grok. So this came up in 1999, and IEEE Intelligent Systems asked me to do a paper on it, which I did, and one can Google it, where I spoke about how one could make use of that for much more efficient search because one could send the query to many different sites and by using instantaneously trained neural network, gather or aggregate all that information, which is what current AI-based engines do. So that's what was in the 90s. And then I moved on to quantum computing and other subjects.
So I want to also ask you about quantum computing as well, and maybe how you went from the instantaneously trained neural networks to quantum computing. Could you describe what quantum computing is and what your research is focused on?
Well, quantum computing paradigm is different from the standard computing paradigm because in the standard paradigm, you have information and you process it. You have an algorithm, you displace information or do whatever operations are necessary. In the quantum world, not one, but any number of pieces of information which may be mutually exclusive can exist simultaneously of quantum mechanics, which is revolutionized all of science because without quantum mechanics, you can't have chemistry. Without chemistry, you can't have biology and so on. So what I investigated for some time was, well, what are the limitations of such quantum computers? And right in the early 2000s, there were a lot of groups working on it. I was also interested in quantum cryptography. So I did what I call a three-stage quantum cryptography algorithm, which one can look up, which was in 2006. And then I did many other papers, but then I concluded that possibly quantum computers will not be built because there is a problem with them that when you store the initial information, right, you have to have a initial problem statement which you operate upon in a standard computer. So here, what you do is you have what are called qubits, which are placed in the superpositions of zeros and ones. And so they are both 0 and 1 at the same time. But keeping it that way, right in the beginning itself, creates a problem because there can be errors. They may not be exactly 0 and 1 simultaneously. And that error can become larger. And so you have to have extra hardware to correct for those errors. But that extra hardware builds up very, very rapidly. It's like standing on top of a ball and juggling several balls at the same time. Because if your base itself is not stable, that instability goes on and spreads everywhere. So now I do know that partly because of the perceived race between the Chinese and the Americans. The Chinese were putting money into it, so the US also thought it was very essential to put money in it. And there were many private companies that got in, including Google and Microsoft and so on. And 5, 6 years ago, they said we'll be uh, out there with practical quantum computers very soon, maybe 4 or 5 years, but that's not happened. And in my view, that's never going to happen. But it's something like fusion. You have fission and fusion for nuclear power, and ever since the 1950s, it's been announced that fusion is just round the corner. Another 10 years, another 10 years, another 10 years. Give us a few more $1 billion. I think that's what's going to be the state of quantum computing as well. And not everybody agrees with me, but I'm a pessimist as far as this technology is concerned.
That's so you mentioned the I think you said the quantum computing helps us with chemistry. Can you?
Oh, not quantum computing, the quantum physics paradigm. You cannot
Oh yeah,
explain why the electrons don't fall into the nucleus because the nucleus is positively charged, the electrons are negative. And
I got you.
only the quantum physics or quantum mechanics paradigm can explain it. Before that, you needed to invent quantum mechanics because classical mechanics in the 1920s, when all these discoveries were made, 1900s, the electron was discovered, maybe 1890s, and then they were trying to figure out, well, why are these electrons in stable orbits? So that was the crisis that physics confronted. And as a response to that crisis, there arose quantum mechanics. And so quantum mechanics is at the basis of all of the modern amazing developments that have taken place, including ICs, integrated circuits, electronics, and so on. So it's the most fundamental of all the sciences, and its amazing axiom uh, is that um, a system, actually exclusive states, and all of those states evolve. So you're solving any number of problems at the same time, that machine. But when you interact with a quantum system, you have access to only one of those states. And
Hmm.
that access is sort of random or probabilistic. And therefore, what you have to do is in a quantum computer, you solve many problems simultaneously. And then the problem that you're really looking for the solution to, you increase its probability through certain operations, and that's what you get. But the problem, as I mentioned, is the tremendous error problem that no one knows how to deal with.
So within the field of quantum computing, how should we think about applying this technology or this research to societal problems?
I don't think you can apply uh, quantum computing to societal problems unless quantum computers were built. But you can use quantum philosophy perhaps to look at larger issues. For example, one of the biggest problems facing contemporary society, especially in the US, is the health issue, the health problem. There is something called the reproducibility crisis of modern medicine. 80 to 90% of all the clinical research which is published cannot be reproduced. And in fact, after it's published, FDA gives approval, for certain drugs, etc. And then people start using those drugs, and then you discover that those drugs don't work. Then people try to replicate the initial experiments, they're not able to replicate them. Now, why does it happen? For a variety of reasons. One is maybe there's a confirmation bias. The researcher wants a hypothesis to be proven, so pushes towards that. Or if there is some element which seems to support it, the researcher grabs onto it. Or maybe the research experiments are not properly designed. But there could be another factor, which is the mind, because allopathy, modern medicine, leaves out the mind. It only looks at the body. And the mind is much more complex, and it's quite possible that as far as the mind is concerned, maybe there are some quantum processes out there. And this is a area on which many researchers are working, the quantum mind or the quantum basis of consciousness. And maybe that is being left out. And maybe if that is taken into consideration, possibly it will provide certain uh, ideas or new avenues for better research, and that'll be good for society.
Yeah. Well, so I want to talk about artificial intelligence for a little bit. And also connecting the dots. So how do instantaneously trained neural networks fit in within artificial intelligence? How does that work?
See, all of AI right now, all the amazing things that are happening, Chat GPT or DeepSeek or Grok and so on, they're based on neural networks. And what they do is they have all the literature or data or text. They're called large language models, LLMs. So these neural networks have been trained on a humongous amount of data. And so you question or query the LLM, and it's able to respond properly. So basically, it is the representation of all the textual information that you have or area knowledge that you have within the network connections of this neural network. So now, as I mentioned in the beginning, neural networks take a great deal of time to train. That's why they're very, very expensive. So my instantaneously trained neural networks could perhaps be used in certain applications because there's no training required. And as I mentioned, right in the mid 90s, we had used it even for stock trading or financial data prediction. And then there were certain financial companies which are using it. And after that, I lost track of what's been done. So it is possible in principle that even in LLMs, uh, these networks, instantaneously trained neural networks, could be used. And now I'm not in touch with researchers who work in this area anymore because my own interests have shifted, but it could still play an important role. That's my guess.
So what are some of the limitations of artificial intelligence right now? How do you think about that?
Well, a lot of AI researchers or scientists in general in this field are motivated by the idea that eventually machines would be conscious. And if machines are conscious, then obviously they could do a lot of the stuff that we do, humans do. So maybe we can just sit back and relax and have our beer and let the machines do whatever needs to be done. But in reality, actually, you don't even need conscious machines because most of what we do is procedural. So even without machines being conscious, machines will take over maybe 95% of the tasks that we do. So those jobs will disappear, and that will be a societal challenge, which I call the one observer theorem, which proves that computers will never be conscious, which is a something comforting because if computers were to become conscious, the first thing they'll do will be to kill off all humans because we complain all the time. You say these are pesky little creatures, we don't need them, right? So fortunately, that danger is averted. Computers will not be conscious, but computers will replace us literally at everything. We will, not just driving cars, decision making, which is already being done right now. A lot of the, applications that we have on the internet, AI applications, they make decisions. They can recognize people, they recognize faces, translate from one language to another. And what else do humans do? Humans are always at the screen and we go from one story to another, which is what computers can also do. So now, okay, so what are the limitations then? from a practical point of view, maybe limitations of creativity, because uh, computers can only do what they've been trained on. And that's why these LLMs, these AI-based search engines, we'll also discover with time that they have serious limitations, some limitations. They, for normal discourse, they're great, but sometimes you would suddenly discover, hey, this is totally nonsense. And the computer doesn't know it because the computer is not conscious, right? The program is not conscious. So now jobs will go away anyway. They don't have to be conscious. And then something else is happening. There is a collapse of world population taking place, very rapid collapse, which has begun in countries of East Asia, in Europe, the white population in Europe, in North America, which is one driver of the migration that is taking place from the global south to the global north. And that happens, everything is going to be upended. Society will be changed, and there are some estimates that world population in 2300 will be only 100 million, which is 1/80th of what it is now. Right now it's 8 billion, and China's population right now is 1.4 billion. By the end of the century, it's expected to be only 350 million, 1/4 of what it is now. And that, all of these things are irreversible. They are like tsunami. You can watch a tsunami from a distance, but there's nothing you can do to stop it. And the collapse of population seems to be like that tsunami. So tremendous changes, and some changes nobody can anticipate as to what will happen to society. And certain things are already happening, like, people in the wealthier countries, young people are not motivated, um, because if you have prosperity, material prosperity, how do you make yourself, get out of the bed and work like crazy, which somebody who's not from a similarly prosperous culture or society does on a routine basis. So all of these things are going to um, very critical or central to what happens to world society.
Yeah. So what do you see as the future of this research in both quantum computing and AI and yeah, and the associated technology?
Well, the research will keep on going, because technology, once it does a problem faster, it gets entrenched. People want to make use of it. And AI, the AI circuits or hardware, they become even more compact, because rather than use, high precision uh, computing chips for solving AI problems. You don't need high precision. You can use low precision, and low precision means that the whole hardware shrinks. So all of this is going to have tremendous applications for any number of any number of areas that we can think of. We already spoken about, say, language translation on the fly, so you can speak to anybody. That is one obvious thing. Clearly, self-driven cars, maybe to a great extent, transportation of other areas as well. So whatever you can think of, machines will be at the heart of the solution, and less and less. And since humans do less and less, people will ask themselves, do we really have to have children? And having children will become more and more expensive, as it already is right now in the US. In the more expensive cities like New York or Miami or LA, it could cost you 40 to 50K per child just for daycare. And not everybody makes that kind of money. So a lot of people can't afford to have children. And that might become even more acute. And these are convergence of, firstly, the cost, and secondly, um, people don't see a reason. They say, okay, we are self-actualized. You have agency. Women say, well, we want a career as well. We can't have children right now, maybe 10 years later or 20 years later. And then maybe it's too late. So whatever the details of the process, all that is happening right now.
Yeah. Well, Subhash, thank you so much for taking the time to share insights and talk about your research. I hope we can continue the conversation down the road.
Thank you, Joe. Really enjoyed it.